So hello, welcome webcast viewers. I want to give you a little tip, which is any time that I'm doing live coding, as I will be doing in this lecture, what I'll ask is you might consider pausing right before I'm about to run a program and try and guess what's going to happen. Or when I'm typing stuff and you think, maybe not in this lecture, but as we get more advanced, when I'm about to do something, you might try coding along. And whenever I'm about to do something, you might try and guess my next move. I've had a lot of fun doing that in math classes where I'm just trying to guess where we're going, and sometimes I'm right, sometimes I'm not. But I find that you learn more by trying to see what I'm going to do. If you just sit there and watch, it's not as actively engaging as maybe trying to guess. Now, I mean, there's obviously a trade-off. You don't want to just sit there and make up your own lecture and then hope I did the same thing, but I don't know, just throwing that out there. Okay, so some announcements for the people who are enrolled in 61B, this current spring semester, things you should know, otherwise you can skip ahead. Project Zero will be out tomorrow, well, today, it's tomorrow, which will be the 22nd of February, 2016, and it will be due 1 week later at 11:59. So for this project, I am going to allow you guys to work either alone or in pairs. And pairs is very new for me in 61B. And the idea, I've been convinced by reading, for example, work by Mike Clancy and Colleen Lewis, that it is a good idea, particularly in our course, particularly with a mixed audience where some people know a lot of Java and some don't, that we make sure that we don't feel like we're drowning at the beginning of the semester. And I'm hoping that pairs will enable you to save all the time that you might have lost if you're working alone and getting stuck on silly syntactical things. So one of the rules for partners is that I want you guys to be about the same level of skill with Java, okay? And just coarsely, the rule we're setting up is that either both of you have taken a Java course before or neither of you in your pair. And the goal there is you really don't want to be the person who doesn't know Java working with someone who does know Java. It seems great because it's like, water skiing, right? You want to get pulled by a fast boat, but that is not the case. We want to turn you into a boat. We want you to have all the strength and muscle of like an engine. Or I don't really know where I'm going with that, but basically, I want you guys to be able to learn a lot. And if you're working with someone who's more advanced than you, they're going to give away things that they don't know they shouldn't be giving away. Okay. Now another, perhaps more controversial rule is that you guys are going to need to work in the same place, right? No telecollaborating. I know it's the year 2016, but I think we can deal with it for 1 week, hopefully. You can complain on the survey, which I would like to hear about if you really hate it, because trying it out. But the idea is I find the in-person communication to be so much higher bandwidth, and I think you'll have a much more meaningful collaboration. Now, I can't enforce that because we're not going to follow each of the groups around, but, maybe we will, who knows. But yeah, so we can't obviously enforce that, but in the spirit of 61B, we ask that you try it, okay? And again, if you decide you don't like it, do it and then write to us and let us know. Now, an important thing is that you should not be dividing up the work. Like, okay, you go write the first method, I'll do the second one, I do the third. That is completely against the whole point of the assignment. This is not a class where it's, can your team manage to lift this heavy bar or whatever, right? It's about the thinking process. And the project actually happens small enough to do solo. Last semester, people only had 5 days to do it, and it was all solo. So this semester, you should not think of it as like the groups are supposed to mitigate the workload. It is there so that you can interact. Metacognition is one of the things that is just so important in learning, right? Whenever you're trying to understand something new, it is great to be able to think about your thinking process, and that's why I think being part of a pair is so beneficial. So I will throw out there that there's this thing called pair programming. In the partnership guide, you can get more information, but it's a way of doing group work, okay? Where each person has a role. It's going to seem kind of hokey, but one person is typing, the other person's watching next to them, and the driver is the typer, and the navigator is calling out things, giving suggestions, saying, oh wait, you forgot to do this, or like, why are we doing this, or what was that? And what happens then is you get this dialogue going, and that is one of the most valuable things about an educational experience, and one of the reasons I think that, say, tutoring works so well, because it's bidirectional. It's not just you beating your head against the wall, it's a conversation. As far as the lateness goes, right, we are going to have some kind of grace period for projects. I will let you know as soon as I can. I'm waiting on some technical details about what Gradescope is going to be able to track so that we can do various things like, well, it doesn't matter right now. I don't need to tell you about the space of all late grading policies, presumably. But yeah, so I'll let you know on Monday. So some tips on Piazza. Now, of course, it's a good idea to search for an answer before posting. That's just a reminder. But maybe some slightly less obvious things. Well, one is The instructors secretly, we're limiting the rate at which we're answering questions. And the goal here is we want to keep you guys from getting addicted to that sweet, sweet rush of an instructor answer. We want you to not be too reliant on us, and instead we want you to be a little more self-sufficient. Because again, I'm trying to wean you off of all of those things like magical auto-graders and always getting answers, because those won't be there eventually, of course, right? I want to get you to be an independent citizen. But of course, as a programmer, you're going to be part of a community. And so we want you guys to be able to talk to each other, as opposed to you put out questions, we answer. And often you guys come up with some really interesting and strange follow-ups, as long as the instructor answer doesn't scare people away and convince them, okay, this is done. Now, one of the most important things on Piazza, and a skill that will serve you well in life, is whenever you're posting a question, you should make sure your question has enough information so that somebody helping out can actually help. So let me show you an example of a great question. Right, I'll shrink this down a little so we don't reveal the secret of whose it is. So here, we'll look at this, and it says, this is just a beautiful post, right? Okay. Hey everybody, why did it say error, void, type not allowed here in this code? So the exact error is posted, the student's code is all there, and then it gives an example of a thing that the student has tried, and the new error whenever they tried this out, okay? So it's got it all, right? It's like just a great American tale. It's got screenshots or example code, examples of what the poster has tried. Secrets. Examples of what the poster has tried out so far. And it also even lower down has a follow-up explaining what the problem was so other students could look. It's just, a beautiful thing. So what I find is that often when I try and pose a question so carefully like this, it's great because someone can actually help me quickly. But then the other thing that happens is sometimes just writing the question so precisely, the answer comes to you. And this happens to me probably 50% of the time. I have something where I'm really stuck. As soon as I write up what it is I'm confused about, I get the answer because I've now stated it clear enough that I understand it. And I'll just throw out there that if there's a chance that one of the members of the staff might need to look at your code, make sure that you've pushed the most recent stuff to GitHub and maybe give your login, like BQD or whatever, in your post so that we can look at your code. So I will mention just last bit of the announcement. So an example of a bad question is this one, which is not from our class, by the way. I took it from someone else, somewhere else, so I don't have to pick on anybody in class. But basically it says testing error. Okay. In my JUnit testing, again, that's not a thing we've learned about, but when I'm creating my own test and asserting, I write this thing here. I keep getting an error. What am I doing wrong? Now this post doesn't say, for example, what the error even is. Right? When is it happening? Is it happening whenever they do Java C? Is it happening whenever they do Java? Is it just like a hallucination when they look at their code and they just like collapse on the floor and they're like, and then they come back to? I don't know. I mean, there's just an error happening. And there's no discussion what the student has already tried. This kind of posts, it's hard for us to help. And yeah, it's frustrating for you. It's frustrating for people trying to help you. So don't do this, right? This is the beautiful post. You want people to weep with joy when they see your post. Like, it's just that good, and not this. Okay, that's it for announcements. So I guess a little bit about today. So today, lecture 2, we're going to be talking about a broad variety of topics, mostly about how we create classes and some subtleties about the static keyword. And before we start, I guess I like to always throw in a random fact. So here, this is a wave forecast. And here, purple means big giant waves, and they're moving this direction. You can't see in the static image. And so I'm just warning you guys, you may not know if you're here in the Bay Area and you're a student in Sp16B, we get really big waves that are cool to look at. So if you ever want to go check out those waves, I recommend going to the Pacifica Pier, which you can drive to or even take public transit to. It's like an hour-and-a-half trip by transit and like 40 minutes by driving. And if the forecast that I've linked up here ever says bigger than 18 feet, right, go check it out. So this time of year, you got like another month and a half to try and get out there. You can stand on a pier right above like 15-foot waves. It's great. Okay, so background information aside, let's get going. The first thing we're going to talk about today is compilation, which is the process by which we're going to take Java files, type check them, do some kind of magic where we turn them into bytecode, and then finally we can run them. What? Okay, well, it'll all make sense soon. So let's start by talking about how we run Java programs. So usually what we have been doing in the videos before this, or the video before this, is I've had a clever little trick in my text editor so that I can push a keyboard shortcut and it runs down here. Okay? While this is a nice tool for teaching and kind of a fun parlor trick, it's not something that you will probably find useful in building large programs. Just trust me. okay? So instead, what we're going to do this week is we are going to learn something that will be useful to you for the rest of your programming career, unlike maybe this little parlor trick here. So what I'm going to do is do a command line compilation and execution. So you are going to be, whether you're in Windows or Mac OS or a Linux-based operating system, doing something like this. We're going to be operating with your files on the command line. This is a very important skill as a programmer. One of the very most important, in fact, is this subtle little soft skill here. So what I'm going to do is, so this command I just run, ls, is listing files, and I can see that in this folder I have only one file, hello.java. Now if I want to run hello.java, like you would do on your computer, and as you'll do in Lab 1, I will do the following. I'll type javac, and then I'll do hello.java. Now here is a tip, right, that I'm going to save you like 40 hours of your life now. Instead of typing the whole name, just push H and hit tab. Okay, see that? Just save that much typing. Now while it didn't matter much then, it'll add up over time. So I press enter, and now something happens, and if I do ls again, I see hello.class, right? So this is a file that the Java compiler created from hello.java, and if I want to execute hello, I now type java space hello. Notice I don't do .class. That's just because that's what the people decided Java should look like. It's for niceness, basically. That's just how it works. So I do java hello, and it runs. Okay. So what javac is, it's a compiler. You've never written one of those, but if you took 61A, you actually have written an interpreter. And so what this interpreter does is it takes this file and executes it, and it spits out hello world. So maybe let's see, a schematic version of all of that. Okay. So generally speaking, whenever you compile and run code in Java, it's a two-step process. I have hello.java. I put it through a compiler program. It produces a new file, hello.class. This file is then put through a new program, or separate program, called the Java interpreter, and then stuff happens, whatever the interpreter is supposed to do. Okay, so it's a two-step process. Now this is not the only way to run Java code, and if you've done homework 0, maybe you could think of a different way, where that's not the way you ran the code. Right? So why make a class file at all? Well, the one big reason is that we get type checking. So whenever you give out an Android program, or sorry, whenever you write, say, a mobile app for an Android, it's all in Java. Well, most of it's in Java. And you will be distributing class files. So these class files have been type checked, which means, as I alluded to in the first lecture, that's a whole class of error that your user need never encounter. You get the error gets caught before it's ever even run. Okay? So it's a way of making your programs safer, in the sense of avoiding ugly bugs. And another reason is that class files are simpler for a machine to execute. So rather than having to parse all of this text and look carefully at all these little symbols, the bytecode's already been arranged in a way that the interpreter can operate more efficiently. And that's something that maybe doesn't make a lot of sense now, but if you take 61C or 164, then you'll get a better handle on that. One reason that is not listed here and is not the case, you might think, well, that way I don't have to give away my code. Maybe I have some secret algorithm here, some very clever idea I don't want anybody to be able to see, so I'll compile it, and I'll just give them the class file. In Java, doesn't matter, right? The class file, not that we're going to talk about the structure of them, but it is possible in Java to take this process and go backwards. You can take a class file and produce more or less the exact same Java file you started with. So just throwing that out there. It's not for obfuscation, but it's for more these reasons. Okay, so that's compilation. Our next topic, and this one's going to be a bit of a doozy, is going to be the definition and instantiation of classes. So we've already done this, but we're going to do a more sophisticated version of what we've seen before. So let's suppose we create a new class called dog, all right? What I'm going to do that's different than before is I'm going to take away the main method. Okay, we'll see why soon. Instead, I'm going to give it a method, make noise, and what that's going to do is bark. Okay. So we can compile this class just like before, and it'll compile just fine. Here's dog.class. But if I do dog, Java dog, I get this error we saw in lecture 1. There's no main method. Dogs don't know how to run. Well, this dog does. Okay, now this file right here, I guess, just for comparison, for those of you who know Python, this file is the equivalent, more or less, of def make noise, print bark. This would be dog.py. Okay, you'll notice that this Python program, right? There's no point where it's calling make noise because there's no main, right? So the stuff that goes down here, this is basically main. Like stuff that lives outside of a function in Python is main. So if I decided to put back main, static void main string args, and then we do make noise. Now, if we recompile dog and run dog, we get bark. Just like down here, we would just do make noise, right? That's the Python version of this. Okay, so it's often the case, though, that classes we create in Java do not have main methods. I'm just going to take this away entirely. Often we'll have, and we'll see why in Project Zero, but so just trust me for now. Often we won't actually have a main method in the dog class. Instead, we'll often have other classes that use the dog class. So I'm going to create dog launcher, right? So every dog ought to be launched. This is a class that, if you're looking at our optional textbook, the dog launcher class will test drive the dog class. So it's just there to show that dogs work. So in this case, dog launcher does have a main method. And what I'm going to do is, okay, my goal is I want to call the make noise method of our dog class over here. So what I'm going to do here is I'm going to say dog.makeNoise. So what this does is it says, Java, I want you to go to the dog class, find the make noise method, and run it. By the way, I don't think I mentioned this before in these videos, but method is just a word people use in Java for functions. So if we do Java dog launcher now, I get a bark, right? So what does dog launcher do? Well, when it starts running, it goes to the dog class, says make noise, and this happens. All right, so that's the core of what defining classes is all about. Okay, so as we saw last time, every method in Java, right? Any code you want to run, it must be associated with some class. Every file contains a class, and all code has to go inside of a class. There's no way to write code that is not inside of a class. And so what we want to do is, if we want to actually run a class, then we have to define a main method, right? If we actually want to run something, we have to have a main. So the dog class, as we saw, as we've written it on the side just now, it has no main method, right? You cannot run it directly. There is no main method. And that's a common pattern. But we could have other classes that have a main method that maybe call methods in our function, other classes, right? So this dog launcher class, it calls a method from another class, which is a nice feature that one class can use another, because that's the entire basis upon which we're able to break down problems into smaller pieces. And so again, our optional textbook, Head First Java, it calls this a test drive class. Now, of course, not all dogs are equal. Here is one noble dog. Here's a different dog. Alright. Not all dogs are equal. And we're going to capture that in our Java code. We want our dog class to be able to, often we write programs that recapitulate features of the real world around us. So we want to, if we're writing dog simulators, we don't want them all to bark the same. So how can we achieve this? Well, one approach would be, for every single dog out there, just make a new class. For Maya the Malamute, this dog here, it will have an aroo sound. For Yapster the dog, I don't know what that dog's name was. Maybe it has this just hideous barking noise here. We could do this, maybe, but this is going to get redundant in a hurry. It's obviously going to be just annoying, right? So instead, what we're going to do is take advantage of the important fact that classes can contain not just functions, right? We've seen classes that just have a bunch of functions in them, but they can also contain data, much like languages that you may have seen before, like Python. And so what's going to happen is we're going to define a blueprint for all dogs. That's the class. And then we'll be able to instantiate it as an object. So imagine you have this ethereal, ideal dog, and then we're going to incarnate it into specific types of dogs, okay? And it'll make sense in syntax very shortly. So we'll create a single dog class, we'll define that, and then create instances of that dog whenever we want to use dogs. And often in Java, those instances, we'll call them objects. They're real things. And then the class, again, as I alluded to earlier, it provides a blueprint that any dog has to follow. And I have a note here for So if you've been through 61A, this seems familiar presumably. But if you're not from Python, say E7, I have a little note that you can check out later. Or I don't know, you can pause the video and read it. So let's see what that's like. What I'm going to do is first, I'm going to say that not all dogs are the same. Some dogs are going to have a property all dogs are going to have a property which I'm going to call size. Okay, this is the size of the dog in standard dog size units. Okay. Then what we're going to do is we are going to create a constructor, it's so called. Oh, wait, nope, I lied to you. I don't want to do that yet. Blah, blah, blah. What we're going to do next is we are going to make the noise that the dog makes contingent upon its size. So if the size is less than 20, we will do hideous yapping noise. Wait. Hideous yapping. Else if size is less than 50. Actually, no. I have a thing I set up. Bark. Else. And then we'll have a clarion call of aroo. Okay. There you go. So those are our different sizes. Okay. Now what? Well, let's suppose we want to create a specific dog. If we try, let's just try running it and see what happens. I don't even know. So if I try compiling dog launcher, I get yelled at and I get some bugs here. Well, there's actually a few. So let's fix this one first. There's no semicolon. But what I get here is this says non-static variable size cannot be referenced from a static context. Okay, so what it's saying here, this variable, okay, and we're going to talk about this stuff later. For now, it's going to seem a little bit magical. It's saying that this is a static context, okay? What does that mean? Well, what it means for us is we're going to take away static. Just trust me for now, okay? So if I try recompiling now, I get another error like that. Non-static method, make noise, cannot be referenced from a static context, okay? So whereas this first one's going to be very mysterious, why we had to take away static here, this one should make some sense, okay? The idea here is that basically right here, what we're trying to do is get the platonic ideal of all dogs to bark, okay? So we create a blueprint for dog, we have a mental image in our idea of what dog is, and we're saying, dog, bark. But dog is just this idea. It doesn't have a particular size. So instead what we need to do, okay, is we need to say, let's say dog Maya equals new dog, Maya.size equals 1,000 units, and then we'll tell Maya to bark, all right? So here, what I've done is created a specific dog that can go and do the barking. Now I know that some of the syntactical things we've just done will be a little confusing. That's fine. You're going to get lots of practice soon. I just want to give you a sense of what it feels like to create and to instantiate and define these classes without going into too much detail about what these statics mean yet. Okay, so now if I run dog launcher, Maya, being a very large dog, will go aroo. Okay, so maybe let's just step through the whole process of what happens when we run this program. The first thing that happens is we create a dog, which we put in a variable called Maya. So this is new dog. Instantiate this dog. Create an instance of the dog. Then tell that dog, hey, your size 1,000, and then tell the dog, go make some noise. And we're able to do Maya.size equals 1,000 because we've said all dogs have a size. And then finally, of course, when the program runs, Maya's size being greater than both of these will emit an aroo sound. Now this is a little cumbersome, this syntax so far. So I will take you now to the state of the art, the kind of code you will be writing. What we really want is, wouldn't it be nice if we could say dog Maya equals new dog and just put 1,000 here and not have to manually set this variable. Okay, so that's our goal. So to do that, now we'll do that constructor thing when I was getting ahead of myself. We are going to create here a so-called constructor. We'll give it a parameter. In fact, I'm going to give it a different name. And this right here, this is a constructor. It tells us how to construct dogs from our ideal notion of dogness. Okay. So when you create a dog, you need to give it a size. We're now declaring. That's what this is saying. To create a dog, you must provide a size. And what does the constructor do? Well, what it does is it takes the dog, which has this personal data, it carries around with it, and it assigns whatever was given to it. It takes that data, right? So the dog is being born, and we whisper to that little dog fetus, "You shall be size 1000." And then, while that dog's being born, it takes on that feature, and then immediately it's size 1000. Okay? So let's try running this. And again, we get Aru. Now we can change Maya's size here, and maybe we decide Maya's a tiny dog, in which case we get hideous yapping. Okay? So that's a whirlwind tour of a lot of syntax in a hurry, but it gives you a flavor of what things will be like. And again, the point of our early labs, and especially our zeroth project, is to get really comfortable with these things. So I don't expect you, having watched this video, to feel like, okay, yes, that all made sense. Okay, so that is the core of creating our dog class. Now, if you're a little iffy on this syntax here, this is the equivalent, right? So those of you who have taken 61A, if you haven't, ignore this. But this is the equivalent of, in Python, doing init self s, right? So if you know this init function, this is that init function. And if you don't know what I'm talking about, don't worry about it. I will throw out there, by the way, that for those of you who really miss self, there is actually a keyword in Java called this that is just like self. But the difference is that you don't have to actually include it in the list of parameters. So, for example, I can do javac dog.java, and it will compile just fine, even though I've done this. Now, this is a special keyword. Like, I can't do like fizz. It'll yell at me and say, no, that's not a thing. All right. So just a little extra for those of you with Python experience, but I'm going to delete it because many of you may not have that experience. Okay, so let's look at the terminology. Okay, so this version's going to be a little different because, hey, I like to make things up as I go, but it's going to capture the same ideas. So if we look at the definition of a typical class, all right, let's look at the terminology here. This is our class name, of course, but then the new stuff is, here I have a so-called instance variable, right? So the instance variables will be all of the information that is common to dogs. Every dog, in this case, has a weight in pounds. We called it size. And you can have as many instance variables as you want. You can make dogs have size, color, shape, rolling technique, whatever you want. You just have to list them up here. And then you can create little explanations for how to construct a dog. So here I've created a constructor that says every dog needs a starting weight, and then we'll set that weight up when a dog is born. So we call this thing constructive, and it tells us how to instantiate the class. Next up, we have here a non-static method. Okay, so this is something that a particular dog can do. A dog can make noise, and if its weight is less than 10, yip, yip, yip. If it's less than 30, bark, otherwise woof, woof. So the basic idea, right? You'll remember that I did this strange thing earlier where I said, I'm going to take away static, okay? I'm taking away static at some point. What did that mean? Well, the idea, the rule of thumb you can use is if this function or this method is going to be invoked by an instance of the class, right? If we have a particular dog doing the barking, it should be non-static. So you know the word stasis, right? It's like, it means unchanging. If something is static, if a method is static, then it doesn't go with a particular dog. That's what the terminology means. So static is something that's like the platonic ideal of a dog can do. Without static, that's something that a specific dog can do. Or maybe another rule of thumb is, if at any point, anywhere here, you are using a specific attribute of the dog in question, right? So this is the dog's brain, basically, here. If it needs to refer to its own information, don't put the word static. All right. So here is our launcher class for this dog class. So a little more terminology. So suppose then, this is a little different than the one we did before, right? So this code should look similar to what we did in our dog launcher. Let's suppose we create a variable small dog. This is the declaration of a dog variable. Okay? Now it's possible you don't have to instantiate a dog when you create a variable. We did in our example, right? If we look at our dog launcher, we said dog Maya equals new dog. We declared the variable, made an instantiation, and assigned everything all at once. But you don't have to do that. You could just say dog, small dog. Here is a funny line where I'm creating a dog. This is an instantiation. So anytime we want to create a dog, an instance of the dog class, we use the new keyword. So new dog 20 here, that creates a dog. Now we'll notice we're not actually assigning it to anything here. So the sad truth here is this dog is created and then destroyed. Now this dog is lucky enough that when it gets created, it's of size 5, it gets put in the small dog variable and it gets to live a healthy, fruitful life, unlike this poor guy. So on this line, we've done both instantiation and assignment. And then often you will see your code will do all of those things at once. We'll declare a variable, we'll instantiate, and we'll assign all at once. And then if we want to actually run one of these methods, we'll call it the invocation or the calling of this method. So when we do huge dog here, dot make noise, this is an invocation of that dog's method. And by the way, for those of you who haven't seen it yet, I mean, most of you are from 61A and have seen this, but for those of you who are not, these dots here, you can just think of it as a belonging operator. So this is basically saying huge dogs make noise method, right? Just as we can set sizes with dots. And so anytime you're seeing a dot, it's saying this thing belongs to something. The make noise method is a member of huge dog. Because you're going to need to do it on Project 0, let's also talk a little bit about making arrays of objects. Now you may recall that in the last lecture I said it's really important that you do homework 0 before this lecture. Here's why. I'm just going to start talking about arrays, assuming you know what they are. If you don't know yet, pause this video, go do homework 0. Once you're done with exercise 2, come back. Okay, so now that we know about arrays, let's suppose we want to make an array of dogs. To do that, we can declare an array of dogs as follows. So I can say some dogs equals new dog 2. Okay. Important point. This creates an array of 2 dogs. But no dogs exist yet. All right. So you can think of it, the array has spaces for 2 dogs. We make 2 dog-shaped boxes, and they're waiting for dogs to come and snuggle inside of them. But there are no dogs yet. If we want to actually put some dogs in those boxes, we can say some dogs 0 equals new dog, in this case, 90. And then I could do some dogs 1 equals new dog, 105. At which point, I now have 2 dogs in some boxes, and I can say, for example, dog in box, actually, we'll make them smaller. We can say dog in box 0, you should go make some noise. And being a tiny dog, it will, of course, make a strange noise. Let's make sure we got our syntax right, okay? So dog in left box, make your sound, hideous yapping, because it is so small. So that's something you should know, because in Project 0, you'll be doing a lot of that, okay? So again, I guess if you want the slide version, it's just here. So to create an array of objects, as we saw in homework 0, you use the new keyword to create the array, and that array has no dogs in it. It just has dog-shaped boxes where you can create dogs and put them. And then use new again for every object you want to put in the array. Okay, so that's creating arrays of objects. Let's now take a closer look at static. So before we kind of waved our hands, it probably seemed a little mysterious. Now what we're going to do is do static the right way, and we're gonna demystify it. So let's start by talking about the difference between static and non-static methods. So what we saw before is we first created, the first make noise method we created a little while ago was make noise, and it was static. And when we invoked it, we had to say dog.makeNoise. So static methods we invoke using the class name. By contrast, we later created a non-static method where we had to actually create a specific dog before calling make noise. And you'll notice here, there is no static keyword. So when you're trying to decide, should a method be static or not, you're asking yourself, is it a specific instance of that class that's going to be doing the thing, or is it a generic thing? Right? Now, I'll give a good example of why this is a useful construct in the slide. But basically here, our decision was it makes more sense to create a specific dog with her own internal life, with a size and a job and hobbies and whatever else. We create that dog, and then we say, Maya, now that you exist, go make some noise. And Maya, based on her own personal attributes, will either yip, bark, or woof. And we see that that is specified in Java by not having static here. So we use the phrase non-static. Now it's important to note that static methods, right, like this one, cannot access instance variables. This is not a thing. Because here, we're basically stating that this is a thing that the platonic ideal of dogs. We're saying, oh great astral dog, please make noise. It would not make sense for the astral dog to try and think about their own size because that dog is sizeless, right? It's just all around us, the omnipresent dog. That was also a really cool arm wave. There you go. All right. So why static methods? Well, some classes are never instantiated. For example, the math class, say we want to round a number, we would say, math class, please take this number and round it to an integer. And this is much nicer than, for example, if we had so this is a static method. If the round method were non-static, we would have to say math m equals new math, which is weird. And then we'd have to ask our math instantiation to round. So that's why we do this. Now there are some cases where a class will have both static and non-static methods. So let's see this example. We'll develop it. Okay. So let's suppose we want a method for comparing two dogs. Okay. So, well, I'm going to call it public static dog, max dog d1, dog d2. And what it's going to do is this is going to return the larger of dog d1 and dog d2 based on their size. So it'll be pretty simple. If d1.size is greater than d2.size, return d1, otherwise we'll return d2. Okay, that's what's going to happen here. So in this case, this max dog function, if we wanted to invoke it in dog launcher, let's say, I guess we have this old example. Actually, for cleanness, let's get rid of this. And let's have Maya the dog, make her large. We'll have Tiny the dog, which will be size 5. And then we could say, because we have this new method, max dog, okay, how would we invoke it? Maybe pause and think about it. Do we do Maya dot, tiny dot? And I'll wait, because you're pausing me. Okay, yeah. The answer, because it's static, is we invoke it using dog. So we say, great astral dog in the heavens, please compare these dogs for me, Maya and Tiny. And this will be, let's say, larger. Okay. And then we could say, larger dog, make noise. Okay. So this will get evaluated, and assuming we didn't mess anything up, if we do dog launcher, dog launcher, we get Aru. So the larger of the two dogs here, which must be Maya, is doing the Aru. If we change this to 30, for example, what was our size? So now the larger of the two dogs will be in this range and should bark. Okay, we get bark. So that's using max dog. So the idea here is just, we feel like it's unfair for any dog to judge another. That's not nice. We could make a non-static version of this method that compares the current dog, right? So we could do public dog, max dog compared to me, something like that. I don't know. It's making it up so it's clear to you. And then in this case, we'd be comparing my own self. So then we would say, for example, if size, actually let's rename this other dog. If size is greater than other dog.size, return this. That's me. Otherwise, we can do return other dog. Okay, so that's an example of how we might write a non-static comparison. Either way. But you may find it from time to time useful to mix static and non-static methods. We can generalize a little bit. And it turns out that in Java, we can have not just static methods, but also static variables. So as an example, right, we could here have in our dog class, we could create a static variable, and a static variable should be capturing something that is common to all dogs. So in this case, I've chosen the scientific name. That's a thing that all dogs share. Even the great astral dog is also a Canis familiaris. So classes, of course, can have a mix of static variables and methods and non-static variables and non-static methods. And we'll use the blanket term member to refer to any variable or method. Okay, so we can have a mix. And just like static methods, static member variables will be accessed using the class name. So for example, I could say dog.binomen, and that will give me the scientific name. And as we've said before, non-static members, they cannot be invoked using the class name. We cannot say dog.makeNoise here in this particular one, right? If you try and say great astral dog in this particular definition where there's only a non-static version, this will not work, right? So just be aware of that. So I would say that you want to use static variables very sparingly. And if you ever find yourself using them, think very carefully. Is this really something that every single dog should share? Right? So like if I made weight in pounds static, that would be bizarre to say all dogs have the same weight. So when you're doing Project Zero, for example, you really should not make, say, the mass of your planets static. Okay? And you'll see what Project Zero is soon if you haven't yet. All right, so that's the core of the idea behind static. And we'll learn a little more later, but that's what you really need to know. Ugh, it became dark suddenly. Okay, well, so there's one last thing that we want to say about static, which is I want you guys to now try and figure out what this code will do. So this class dog loop, I want you to tell me, will it compile? And if it does compile and we try to run it, what will it print? And let's say that the dog class is defined so that for less than 10, size less than 10, it yaps, for less than 30, it barks, and for greater than or equal to 30, it woofs. So you can either pause the video right now, or you can go look at the slides on the website and look at it from there. And when you're ready, you should try and click this link to check your answer. So I'm not going to go through it myself because I'm just a robot on the internet, and I believe you will have a more interesting time trying it out yourself. It's not like we can really communicate and ask questions of each other. Sorry, I'm just a recording. Let us now return to the mystery of public static void main string args. Okay? So we look at this. This is actually something we can understand now for the most part. Okay, so first off, you should ask yourself, what is this thing? Okay, well, it's a method. Now some questions for you that you should ponder. What is the name of this method? Main, right, or wrong? I don't know. I can't hear you. How about this? What the next question I have for you is, what is its return type? Right? Methods have return types. Yeah, it's right here. It's void. It's nothing. We don't return anything. Is it static? Yes. And does it have any arguments? Yeah, it does. It has one argument, which is an array of strings. So just like all the methods we've made, like max dog or make noise, or if you did homework 0, the drawing triangles, this is just another method, right? There's nothing super magical about it. And so what we're going to do now is demystify what this piece is all about. I mean, like, this makes some sense, right? It doesn't return anything. It's called main. It's static. So the next question is, what about this? So let me give you an example of how we can use that args, right? Okay, so let's create now a new file, which I will call, nope, incorrect. I will instead call it, args demo. Okay, so args demo, what it's going to do is I'm just going to play around with args, right? It's just a thing. I should be able to access it. So I'm going to say system.out.println args0, right? So it's an array of strings, a bunch of little beds that strings can live in. And so if I now do java c args demo, and I say java args demo, it should run. But I get exception and thread, index out of bounds. And let me interpret that for you. It's saying that while there is an array of strings, there's nothing in the 0th position. There aren't enough items to be able to get the 0th one. Now the question arises, well, where do these args even come from? I mean, I can't, like, suppose I didn't want that to happen. I can't do like main, I can't do like string some strings equals new string 5, and then like some strings 0 equals hello, main some strings, and so forth, right? I can't do that because I'm not actually calling main. The interpreter is calling main, whatever that means. So how can I actually get more args? Well, those of you who've seen another language where you've used command line arguments will know that it comes from, if we're doing a command line execution, now you're seeing why I'm not doing this in Sublime, I can put the arguments right here. So I'll put like thing 1, thing 2, thing 3, thing 4, right? Or how about, I don't know, A, B, C, D. A, B, C, D. So when I do that, what happens is this is considered arg0, arg1, arg2, arg3. In fact, let me demonstrate with code. So let's say I do index equals 0, while, geez. Okay, that's interesting. While index is not my normal keyboard, because my normal keyboard is incredibly loud. Sounds bad on this microphone. So while index is less than args.length, index plus equals 1, and then I will, before that, print out args index. So So what that will do is it should go through each item of my array and print it out. So in other words, okay, maybe a good test for you is, what's going to happen when I do this? Think about it. Okay, we run it, we get ABCD. Prints out each of the args one line at a time. Okay, so why is that useful? Well, any program you run from the command line, you need to be able to give it input somehow. And if you've used some commands like ls, for example, it takes command line arguments. I can put lsl. I'm telling ls to behave slightly differently than usual. Usually when I do ls, I get a list of files, but with L, I get all of their file names. Okay? Just so you could use the args to control the behavior of your program, and indeed in Project Zero, you will be doing exactly that. Okay? So in the old days, programs were all command line. I mean, that was what we did. Nowadays, maybe you don't use the command line very often, so it's not natural to you. But that's why. It's a way that you can give input to your program. That's very natural and convenient. In fact, we're using command lines all the time, right? There's a command line to Java-C. It's argsdemo.java. Okay. So what we can do next is I want to show you maybe doing something a little fancier with this. We're going to do, I'll call it args_sum. So the goal of this program, I named it untitled. That's bad. args_sum.java. Okay, what this program is going to do, this program will sum all the command line arguments, assuming they are integers. Okay. And so what's going to happen now is I need to modify my program so it behaves like that. So in other words, what I want is I want to be able to say Java arg_sum 1, 2, 3, 4, press enter, and have it actually print out 10. That's the sum of these numbers. 1 plus 2 is 3, 3 plus 3 is 6, plus 4 is 10. Okay, how would we do that? Well, I'm going to set up a total variable. And then instead of printing each one out, I'm just going to say total plus equals args index. Okay. Actually, maybe to make it extra clear. Total equals total plus args index. So it goes through each arg and adds them up. And at the end, it will print out the total. So let's try compiling args_sum. Okay, we get string cannot be converted to int. Why is it trying to convert a string to an int? Well, it's because we're trying to add what is a string to an integer. So those of you who have had experience with languages like Python, you might be tempted to do something like that, right? That's a pretty natural thing for people from Python. But in Java, that is not the appropriate syntax for conversion, right? In fact, it'll yell at you and it gives an error message, which is basically useless. Like, that doesn't tell you anything hardly. It's confusing. So the question is, what do you do, right? You are going to have to deal with this problem time and time again as a programmer, especially on Project Zero. We have not told you about all the things you'll need. We want you to be able to go out there and find the things you need for common tasks, right? I mean, we could have spent like 2 extra weeks in the class talking about like, how do you round numbers? What are all the various parts of the math library? But instead, I want you to be more self-sufficient. So the thing you want to do now, and literally this is the thing you want to do, is you say Google or Bing or whatever you want, and type out some search, like convert string integer Java, let's say. I don't know why I have caps on, but hey. And then I go, I don't know, the first one, and it says converting string to int Java. It sounds about like what I'm trying to do. In fact, somehow this post has 1,379 upvotes. And there's answers, many of them, in fact. So someone here has given the best answer, and this is a great thing for you to do. I encourage you. In 61B, you really need to learn this skill. To be a good programmer, you need to know how to mine the web for relevant code. So in this case, it says int foo equals integer parse int. Okay, so this seems to be the way of converting what is here a string into an integer. And this person has been nice enough to actually link us to the Java documentation. We'll look at that in a moment. But for now, I don't know, let's just try it out, see what happens. You're not going to explode your computer by just trying things. I mean, probably not. Certainly not something like this. I mean, if we were trying out a function like, how do I delete all the files on my computer? Maybe don't run that one. But for this one, we should be good. So what I'm going to do is I am going to assume, it looks like to me, this is a function, integer.parseInt, and I'm just going to take this up here. And I'm going to say, okay, well, instead of doing 1, 2, 3, 4, I'm going to put my thing in. I'm going to hope that's right. Okay, that's one way you might approach it. Like, you have a rough idea of how this is supposed to work. And if I try that and run it, in this case I was lucky, right? Like, the gut feeling I had was good. And so I encourage you to be lazy, but not too lazy, because sometimes it'll bite you, right? Where you just like copy and paste something into your code and you're like, I think it worked, but I'm not sure. So it's often not a bad idea to then turn to the documentation and just make sure you really got it. So this person's linked us directly to this, which is nice. And so this documentation is, something we can actually even understand given what we've learned today. So we have here public static int parseInt. Okay, so it's a static function. It's part of the integer class. All right, we could see that here, integer class, and it has a static method called parseInt. And what does it do? Well, in this case, there's actually multiple versions. So we're a little, not quite a match. They were close. This is the one we're actually looking at. Sorry. So our link from our post wasn't quite the right one. But here it takes in a string and it returns an integer and explains what it does. Parses the string argument as a signed decimal integer. And there's a little bit of stuff that we haven't learned in 61B yet, but basically we can read it. And one thing I have to say in Java's defense is that it has great documentation. Often libraries are just beautifully documented. Okay, so there you go. Okay, and for those of you who want a written reference, here they are, but we don't need to go through this now. All right, so that's effectively a sense of what I expect you guys to be able to do. Command line arguments would be tricky to learn on your own, but I really want you guys to be able to Google things like converting strings to integers, being able to break things down into the little pieces you really truly need, and then finding solutions to those little pieces is one of the most important skills you'll get in 61B. As our last topic of the day, I want to talk a little bit more about using libraries, and these are a couple that we'll be mentioning soon. So as a programmer, you want to use libraries wherever you can. What is a library? Well, it's just a collection of classes that do useful stuff, right? Like rounding numbers or converting strings to integers and so forth. You could, in principle, rewrite all of that stuff, but that would be a waste of your time. So any place where we feel like we don't want you to waste your time on that sort of thing, we'll make sure that you have the right library. So as 61B instructors, we'll make sure you have those things. Now that'll include, of course, all of the built-in Java libraries, like the ones we've already seen so far in this class, others that we'll see in a few weeks. But it'll also include some external libraries, things that are not part of Java built in that you had to set up in Lab 1B. So for example, that includes the Princeton Standard Library, which is, I'll say more about it soon, but this standard draw lets you draw to the screen easily. Standard audio plays sounds beautifully without much work, and in lets you read files. And then when we get to project 2, we'll almost certainly be using the Java FX library, which will let you build graphical user interfaces. So as a programmer, to avoid reinventing the wheel to write these menial programs, you'll want to use these libraries whenever you can, and that'll save you the trouble of having to build these things. But of course, you're going to have to figure out how the library works. Okay? So how do you do that? Well, we've just seen Google a little bit. So I just want to list off maybe different ways you might approach using a library. So if you have an unfamiliar library that you want to use, for example, in Project 0, we're going to throw a bunch of classes at you. To figure out how to use them, you're going to maybe, well, if you're lucky, you can find a tutorial out there on that someone's provided for that library. We sometimes provide those. You could read the documentation for that library. And one thing that's nice about Java, as I mentioned earlier, is that the documentation for classes is often really good. And another is to find code snippets that someone has written, like we did on Stack Overflow. You're like, okay, that's a piece of code I can steal. Now, I will mention that if you're someone who's a little more advanced, I don't want you to go to the web and download these big crazy libraries like the Apache Commons library. They won't work with our grader, so we ask that you use the provided libraries only, and that won't really come until we get to Project 2, but let's just stick with the default libraries in our course. And we may revisit that later if we find that there are things we really want, but for now, I'm pretty sure that you don't want to go into external libraries. We'll let you know if we decide it's safe. Okay. So as an example of this documentation, I have this more here for students who are only browsing the slides. We've already seen this, so hey, we'll keep going. Sorry. And so I will just mention in closing that this Princeton Standard Library is going to be the cornerstone of Project 0. Because what you're going to be building is a simulation of planets orbiting in space and drawing a graphical visualization of this whole thing. You'll be reading input files. And so I have many teaching heroes out there. For example, Dan Garcia, John De Niro, Stuart Regis at Washington, and Kevin Wayne, who I worked with at Princeton. And so he built this library there that makes all of these things much easier. And so what I want you to do is, in Project 0, there's going to be a point where you're faced with this weird brick wall where you're thinking, but how do I really read input files? So we're going to give code snippets that you should look at. And we want you to try and learn this process of, even if I'm not spelling out to you exactly how the in library works with slides and examples and little worked out homeworks, I want you to start figuring out, given a library out there on the internet, how can I figure it out from existing resources? So that's it for this lecture. Let's call it a day, and yeah, prepare yourselves mentally for Project Zero. I think you'll like it.